Okay, good morning all. I hope everyone had a great relaxing weekend. Okay, so let's get started with today's topic. So today's topic is going to be VPCs and subnets. So this week is going to be more around networking and AWS security, right? So that's where this week is going to be primarily focused around. As I said last week on Saturday, this is going to be a very important fundamental foundation that all of you are going to learn, right? So this is the basis for a lot of things that you would do in the future as well. And once you start building systems, once you start managing AWS environments for your organization, this becomes all the more important to understand the AWS security and networking foundational components. So initially, I mean, just a disclaimer here, initially it might look quite abstract and very theoretical or very hard to understand, but trust me, I mean, over a period of time, you will get used to it. And once you do a couple of lab sessions, once you complete a few hands-on exercises, assignments, I'm going to give an assignment at the end of today's session. Once you complete those, you will feel a lot more comfortable. So please stay with me, and I'm sure you will be able to catch up with it very well. Okay, so I'm going to share my screen. Just give me a second. All the other stuff. Let me share my screen. Okay. We're going to talk about VPCs today, right? So, but before we get into VPC, I want to introduce you to something which is very important, right? So the other day we saw the global infrastructure, the AWS global infrastructure, correct? Which comprises of many regions. It comprises of 25 regions across different continents and across the globe, right? That's the way AWS is able to serve pretty much every part of the world. So that's basically the first level of containerization that AWS has, right? In order to offer a globally available service, AWS has built several regions. Each region is a geographical location. Like for example, we have in India, we have Mumbai. Okay, so Mumbai is a geographical region, and so that's the way a region is defined, and that's the way a region is built. It's a geographical region where it's present in a place, which is a vast area and which has got a vast coverage, right? So now the second region in India is coming up. It's in Hyderabad. Okay, Hyderabad. So Mumbai is basically the west side of India, right? So Hyderabad is basically the central region or south central region in India, correct? So that's a separate geographical location. So now the way Mumbai and Hyderabad are decided, correct? Similarly, in US, you've got North Virginia, you've got Northern California, you've got Oregon, right? And similarly, in Europe, you have Ireland, you have Paris, you have London, correct? So now the way these regions are decided is based on they are in a different earthquake regions. Okay, they're called seismic zones, right? So it's called seismic zones. They do not belong to the same plate, right? You've got the tectonic plate, correct? So they do not belong to the same plate. So which means that at a higher level, they belong to a different seismic zone, right? So which means that if there is if there is a earthquake in one region, it does not, basically the blast radius of that does not extend beyond that region, right? Beyond that plate. So which means that scientifically they've analyzed the data from the last several years and they've decided, because building a new region needs a lot of investment, right? I mean, it's several billions of dollars. So from that perspective, what AWS has done is they have done a lot of research based on data coming from last several hundreds of years, right, on the seismic activity, and they decided to build their regions in such a way that in India there are two regions, right? So even if one region was not available for whatever reason, right, due to earthquake or other natural calamities like monsoon rains, cyclones, or in US you have tornadoes very frequently, right? So now because of those, if any of one of the region is not available, at least there is another region that is available. And if you have built your application architecture in such a way that you are taking advantage of the multi-region architecture, so then it will allow you to be resilient, be more resilient. Right? So that is the reason why we have got multiple regions. So for all purposes, region is a geographical location. Okay, and usually the data, when you deploy a data in one region, the data doesn't cross that region. So that's a compliance and regulatory requirement. Okay, so it cannot cross that region. AWS does not take your data from Mumbai region and put it in Hyderabad, or it will take your data from Hyderabad and put it in Singapore. They will not. They will never do that. You have to do that. I mean, if you want to spread your data and application availability across multiple regions, then it is your responsibility to build such an architecture. But AWS will never do that. That's the that is the compliance that AWS adheres to, right? So because many organizations go to AWS or go to cloud because they want their data to be in the country, within the country, right? It should not cross the country. That's the reason why AWS does that. So now there's one more level of abstraction called availability zones, right? So now there are various regions. As I said, Mumbai, right? In Mumbai, there'll be multiple data centers. The other day, I showed a video, right? So where North Virginia, there are about 50 data centers, right? North Virginia is the first ever region for AWS. So now North Virginia has got 50 data centers in it, clusters of data centers in it. Now, an availability zone, right, is, let me just open up the official definition for those. Yeah, if you see, these are the, if I go to Asia Pacific, and this is India. Okay, so now what is a region? AWS has the concept which is a physical location around the world where we can cluster data centers. We call each group of logical data centers an availability zone. Okay, so now what is an availability zone? An availability zone is one or more discrete data centers with redundant power, networking, and connectivity in the AWS region. Availability zones give the customers the ability to operate production application database that are more highly available, fault tolerant, and scalable. That would be possible from a single data center. All AZs in AWS regions are interconnected with high bandwidth, low latency networking over fully redundant dedicated metro fiber, providing high throughput, low latency between AZs. Okay, so now there's one more thing, right? If you see here, if an application is partitioned across AZs, companies are better isolated and protected from issues such as power outages, lightning strikes, tornadoes, earthquakes, and more. AZs are physically separate by a meaningful distance, many kilometers, okay, from any other AZ, although all are within 100 kilometer of each other. Okay, so now for example, if there is in Mumbai, right, if one AZ is in say South Mumbai, the other one would be in somewhere in North Mumbai, right? Probably around, a 90 to 100 kilometer range. That's how it is split. But they are connected. They're connected by low latency networking, right? So that it provides a very high throughput, and the latency between these two availability zones would be sub-millisecond. Right? What is latency? Latency is a term that is used to measure the network round trip, right? How much time it takes to hit and come back. That is called the latency. When you ping a server, that is called latency. You will get a time, correct? So that's called latency. So now you may ask, right, why do we need availability zones? See, availability zones are the actual region is an abstracted concept, right? Region, if you see Hyderabad or Mumbai or North Virginia, they're called the regions in general. But availability zones is where the actual data center is present, right? An availability zone may consist one or more data centers clustered together. Okay, called an availability zone. So now that is the actual physical entity, availability zones, right? So now the way AWS has split the availability zones is each availability zone is spread by 100 kilometers. So that way, if there is a flood, right? I mean, if it rains in say North Mumbai, it's not necessarily that it should rain in South Mumbai also, correct? Because the distance is quite high, right? So quite large, so it need not rain. So if there is a flood in South Mumbai, it need not mean that there's a flood in North Mumbai also, right? I mean, there could be exception scenarios, but in general, that's the way it works. So from that perspective, an availability zone is the one where you will have a decent distance segregation between different data centers, different availability zones. So that way, when you deploy your workloads, right, you actually deploy it in an availability zone. You don't deploy it in a region, because as I said, region is just an abstracted concept. Availability zone is the one which will actually host your applications. Okay, so now you can build highly available architectures, right? When you say high availability, if the underlying hardware fails, or if something happens to the underlying data center, then the whole application would go down. If you just deploy it on only one node or one cluster, correct, or only one server. But now imagine a complete availability zone going down because there was a flood in somewhere in South Mumbai, and the network connectivity is completely cut off. No networks are there, no power is there, right? So power is important, right? So from that perspective, you can still serve your application from the other availability zone, which is in North Mumbai. Okay, if you deploy it across availability zones, okay, you will see all of this. But right now, just imagine that availability zones are more discrete data centers with redundant power. When you say redundant power, usually what happens is in data centers. So for our house, what we do is we have power supply, correct? But the power supply is from only one provider. Okay, if that energy provider has some issues, or if that grid has some issues, then what will happen is we lose power at home. But data centers are not built like that. The data center will have redundant power supply. They'll have power supply from two different providers. Even if one provider or one grid goes down, there is a second grid that is available to supply the power. Okay, it's like you take a flight, right? I mean, you take a Boeing aircraft or Airbus, right? Usually the way aircrafts are built is it will have a lot of redundancy built in, right? Even if one part fails, I mean, usually the long haul flights that you see have 4 engines, not just one. Usually flights have 2 engines, right? Left engine and right engine. So even if one engine fails, the other engine can manage the flight and it can land, right? So it can do an emergency landing. But long haul flights have got 4 engines. Right? Similarly, if you take the electrical systems or if you take the power systems within the aircraft, everything will be redundant, right? So redundancy is very important for to enhance the fault tolerance. Fault tolerance, that's a very important word, right? When fault occurs, how tolerant is your system to manage that fault, right? So from that perspective, it's important that you understand. Hello, yeah,
Excuse me, sir.
yeah.
You said the system is built with many redundant things. So it means that if we store our data in one of the Amazon data centers, does it mean that our data is also replicated in some other data center of Amazon?
No, I'll come to that. I'll come to that. Not necessarily. It depends on the type of the data service that you're choosing. If it is a managed service like S3, then S3 data is replicated by default across availability zones, but it stays within the region. It does not cross the region. But like EC2, right, it does not store it in other region. You have to do it, right? So that it depends on the region. It depends on the specific service that you choose. But by default, no. Answer is no.
Okay.
Okay. Yeah. So that way, there's a redundant power networking and connectivity in an AWS region, and it's spread by a distance of about 100 kilometers, right? So that way, any natural calamities that may occur to one availability zone need not impact the other availability zone, or might not impact the other availability zone. Okay. So that's what you need to understand. And availability zone is within the region. Okay, region, and each region will have a minimum of 2 availability zones. That's how AWS will design the region, right? If a new region is coming up, right, like for example, Hyderabad region is coming up in India, it will launch with a minimum of 2 availability zones. Okay, it'll AWS will never launch a region with a single availability zone. It will have a minimum of 2 availability zones, right? Even when Mumbai launched, there were 2 availability zones, and then the third availability zone was added later. Okay, so that's how things work, right? So now if you see, Mumbai has got 3 availability zones, 1, 2, and 3. Okay, there are 3 availability zones in Mumbai. So for now, just understand this, right? And let's get into a little bit of a whiteboarding, right? I've got something out here. Let's get into a little bit of whiteboarding, because we're going to get into the concepts of VPC and subnets. So it's important, and IP address and some things like that. It's important for you to understand. So now these are some of the terminologies that typically we use in networking. Okay. So now I'm sure a lot of you would be aware of everything, or some of you would kind of be at least familiar with a few of these. Right? Are you able to just go through this list for a minute? Okay. Just go through this list and just try and absorb and try to correlate some of these with what you have learned in your colleges, as part of your engineering. Just try and correlate. See, if you all learned the TCP/IP, right, the OSI model, right, Open Systems Interconnection model, then you will be very familiar with a lot of these things. Okay, don't worry, you will get introduced to some of these in the next subsequent classes, but I just want you to be familiar with this terminologies, right, before you jump into it. And in case if you're not familiar, you can just go to Google, search for these, and take a Wikipedia article and read about it. Okay, IP address, NIC card, firewall, a modem router. Modem router, everyone is aware of, right? Because all of us use at our homes, modem and router. A gateway, a switch, ISP, VLAN or a subnet mask, a VPN, a DNS, DHCP, data center. Of course, we have been speaking about data center the last 2-3 days. Ethernet, hub protocol, proxy servers, encryption. Okay, so now these are some of the terminologies that is used, while you design networks. So now let's slightly go a little deeper into a network, right? What is a network? Can somebody just answer what a network is? Nobody wants to attempt?
Network is a connectivity between two or more devices with each other.
Excellent.
So network is a medium which uses to be connection, which uses to connect the two or more devices, or something like any internet or the connection between.
Excellent, excellent. Thank you.
Network is the bond.
What
We
else?
can share resources between two or more computers.
Okay, perfect.
Network
What
is
else?
a medium which is helping in sharing the information across the global devices.
Okay, perfect. What else? What is internet?
Group of connections.
Sorry, come again.
Interconnecting of networks.
Interconnection of networks, right? Yeah, good. So basically, an internet is a network of networks, correct? I mean, a network is where you connect multiple devices together, correct? Like in your home, you might have a small network, correct? I mean, all of us have, right? So because you have a modem, you have a router, and all the devices in your home, such as laptops, mobiles, TVs, any other devices, cameras will be connected to that modem, right? It's a small network, correct? And similarly, if you take a large network, organizations, right? So then organizations, when you look at organizations who have, say, lakhs of employees, right? Or thousands of workstations, they'll all be connected through a network, a common network. Okay, so usually what a network has is it has cabling, right? So cabling is the underlying way to connect the network, right? It has cabling. Cables can be multiple types, right? I mean, there's something called Cat6 cables, right? So the blue cable that you see, that you connect your modem with your router, or you can connect your laptop to your router or a modem, right? So that blue cable that you see, right? So that's called a Cat6 cable. Okay, it'll have a network. It'll have this thing called RJ45 connector. Okay, on the end of it, right? So which you plug into your network interface. Similarly, you take telecommunication. Telecommunication has got a network, right? So traditionally, networks have been copper, right? I mean, usually we use copper to transmit the data, right, over networks. But now these days, copper is being replaced with fiber optic cables. Okay, because fiber optic is more faster, more reliable, and I mean, it can provide you a better data transfer rates and throughput than a copper cable. So cabling is important. Then you have switches where, like, if you take your modem, right, you will have like 3 or 4 ports which you can connect to, correct? Because it's a small device, it can only support up to 4 or 5 connections to that particular device. But you take large networks, usually there will be switches. It's called the switch, right? So where you can go plug your cables in and you connect one device to another device through that switch. Okay, that's called a switch. So then you have, so now let's assume there is a building with say 3 floors, right? And you want your devices to get connected to between all the 3 floors to your corporate network, and you want to call that as your corporate network. So what will happen is you will have a switch. It's called the L3 switch, layer 3, right? Okay, so what are the 7 layers of OSI TCP? Can somebody give those 7 layers? What those 7 layers are?
So,
7
physical
cores.
layer, data link layer, network layer,
Application layer.
transport layer, application layer.
No, you missed 2 in the middle.
Yes.
And presentation layer.
Physical layer,
Physical
data
layer.
link layer, network layer, transport layer, session layer, presentation layer, and application layer.
Yeah, these are the 7 layers, right? Physical, data link, network, transport, session, presentation, and application. Right? So these are the 7 layers of this thing. So in this, what is layer 3? Physical, data link, network. So sorry, please go on mute.
Network.
Please go on mute. Yeah. So network is the 3rd layer, right? So now that's why usually the switches are called. It's because it's at the network layer, right? I mean, where it the physical is taken care through the cables, and data link is also taken care. So this is the network layer, right? So where it brings some amount of abstraction in terms of connecting multiple networks together. So now you have a 3rd floor, and you want to connect all the devices, laptops, desktops through, right? So now you will have a switch in the L3 in the network layer. So there will be a small hub room, right? Every floor will have some sort of a hub room, which will have a small rack. That rack will have different stacked network switches manufactured by somebody, and then it will have power, cooling, and everything, because that's also will generate heat. So now all your devices will be connected to that. Okay, so now these are all individual devices, laptops or desktops, which is connected to that, and eventually that is connected to the network. So now you have different floors, correct? This is the 1st floor, this is 2nd floor, this is 3rd floor. Okay, so now there will be a core switch, right? So these are all edge switches. There will be a core switch, and all these individual switches coming from individual floors will get connected to the core switch. Okay, and that core switch in turn will get connected to the internet. A router, there will be a router or the modem which will be connected to the core switch, right? And this core switch will be able to route the traffic to internet through a router or the modem, which you and a connection that you take from an ISP. Okay, what is ISP? Internet Service Provider. Okay, and then you will also have a data center. These are all end user devices, such as your laptops and desktops. But you also need servers, right? Like somebody asked the question the other day. Having AWS or data centers, would that mean that, you know, the laptops and desktops will go away? No, they will not go away, because these are 2 different things, right? So a desktop cannot replace what you see in the data center, like the servers, the server class infrastructure. Okay, so that's the reason why you need a data center. So again, the data center will also be connected. So now all of this is connected together, right? So this is a full network, right? It is a private office network. This whole thing that you see inside that red box, it's all private, right? Only if you get into the office and you connect your device, or you get plugged into your Wi-Fi, then you'll be able to access this network. Okay, and similarly data center. Now data center will be running some applications, right? Private applications, which is accessible only from inside the network, right? Like let's take a bank, right? A bank will have a data center. These are all the tellers of the bank, correct? Or clerks or cashiers, right? Of the bank, agents of the bank, right? So they'll all occupy one seat, and the actual core banking application will be running in this data center, right? And you visit the branch and you ask for some query, or you want to do some transaction, you know, the teller would be able to make the transaction, which will get stored in this data center within the private network. So now if the teller wants to send an email outside, right? I mean, I've applied for a loan, and if the teller wants to send an email or the officer wants to send an email, that email will go through this. It will go to the router model, and then it will go to the internet, and it will reach me. Right? If he wants to send an email to my Gmail address. Okay, that's how the connectivity works in a in the actual networking world. Okay, so this is at a very high level layman terminology. I just wanted to give you this so that you understand, how the networking works at a very high level. Okay, so now let me come back to this later, right? I'll come back to this later. So now this is how a networking works. Okay, so now let's go back to availability zones and regions, right? So now in case of an availability zone or a region, so if you want to say set up your AWS, okay, what you need an account, which you already have, and then you need to decide which region you want to start building your workloads, start building your infrastructure. Okay, in this case, you want to build it in Mumbai. Fair enough, you do it in Mumbai. Within Mumbai, there are 3 availability zones in Mumbai. Okay, and you want to choose a couple of them, right? Maybe 2 or all the 3, and you may want to choose one of these availability zones to deploy your workloads. Okay, so now these are the bare minimum things that are required. But now once you have decided all of this, you have to start building the workloads, right? So then you need some sort of a network within AWS where you can build a private network of yourself within the public cloud. Okay, so that you manage it and you maintain it, right? And that network belongs to you, because that's the power of cloud, right? So that's the nature of cloud, right? Like I'll again go back to my favorite power example. When you request for a power connection at your home, right? What happens? There is a network that is built within your house. What is that network called? That network is with cables, with power cables. What the electrician does is he connects the entire house, all the sockets, fans, lights, and everything using that power cable, and then he brings all that power cable to a junction box, right, at your main connection where the power is terminated. Okay, so now this entire setup that you see, right, in your home, which includes your main connection plus the various different cables that run through across your entire home, which carries the power to various different rooms, and it powers your electrical appliances. All of that is connected. Okay, so now when you request for a connection, what the electrical company would do is, the power supply company would do is, they'll come, they will draw the power from the nearby pole or a transformer, and then they will connect your main board with the power along with the fuse. Correct? That's what they do. But the rest of it is your job, right? I mean, some company is not going to come and design your design your infrastructure with respect to what cable should I use, right? How many power sockets do I need at home, right? What sort of power socket would I go for? Will I go for Legrand or will I go for Anchor or whatever it is, right? And they're not going to tell you what appliances I need to use, right? So that's all purely up to you. Their job completes when they terminate the power supply at the main board. From there on, it is your responsibility, right? The same thing applies here also, correct? VPC is called a virtual private cloud. Okay, even though it's a public cloud, VPC allows you to create a private environment for yourself so that you can start designing that private environment as per your requirements, and you can start deploying your applications within your private environment. Okay, so now if I build a VPC and if I provision an EC2 instance within my VPC, that VPC or the EC2 instance can only be accessed by me. Okay, no one else, no other customers, right? So for example, there's one more customer alongside me, who is also building his own VPC within his account. His VPC won't be able to talk to my VPC by default. Okay, remember that. So that's the level of abstraction that a public cloud provides you, right? So imagine, I mean, this is a very important concept, right? I mean, a VPC is a logically isolated component. Okay, what is a VPC? If you see the definition of VPC, Amazon VPC gives you complete control over your virtual networking environment, including resource placement, connectivity, and security. The first step is to create your VPC. Then you can add resources to it, such as EC2, RDS. Finally, you can define how your VPCs communicate with each other across accounts, across availability zones or regions. Okay, so now if in this case, if you see, there is a region 1 and region 2, and there's a VPC, right? And subnets, I'll come to subnets in shortly, right? You've got EC2 instances. So this is how they're segregated. Okay, so now usually the way we should learn this is you have to go to resources. You have to go to the VPC page, just read through this, and then go to the resources. In the resources section, you will have technical documentation. So click on this technical documentation. It will take you to the public documentation of VPC. What a VPC is here, click on user guide. Click on this user guide. Yeah, so this is Bible, right? It gives you everything. So VPC enables you to launch AWS resources into a virtual network that you have defined. This virtual network closely resembles a traditional network. Okay, remember this. It's very important. The virtual network closely resembles a traditional network. A traditional network is what I just showed you some time back, right? So this is a traditional network where you've got switches, you've got physical devices, you've got a physical data center, and you connect everything through cables and everything, right? So now, but in a VPC, all of this exists, but in a virtual form. Okay, and shared between multiple customers, shared between multiple different accounts, underlying infrastructure, I mean, but not the data, right? So the data that you store and you transmit is only at your VPC level, right? So there's that you can be 100%, 200% be sure of. Okay, so that's called a software-defined network, right? I mean, if you closely follow some of these advancements in the technology, virtualization is one very, very important terminology, right? I mean, I would strongly recommend you to take a note of this. Read about virtualization, right? What virtualization does, right? It in a single physical host or a single physical computer, you can create multiple virtual computers. Okay, that is what virtualization does, right? It creates a multiple different tenants, and it creates so that way, it does not. If say there are 3 virtual machines that are running in a single physical box, each virtual machine is on its own, right? It does not know that the other virtual machine is running. That is a level of abstraction. So similarly, in networks also, when traditional networks started becoming a big pain to manage because of its complexity, there's something called, I don't know, somebody has to go on mute, please. Please don't unmute. Yeah. Thank you. So there's something called software-defined networking that came in, right? Software-defined. Defined networking. Okay. So it's software-defined networking is something very interesting. You can read through this Wikipedia page, right? It's very interesting. It shows you the evolution of how the software-defined networking came in, right? So I mean, physical networks are still there, but they are a lot more simpler. And software-defined networking gave a lot of opportunity to, abstract the whole networking so that it can be very well utilized, right? So that's where the whole software-defined networking came into existence. So the important thing is this virtual network closely resembles a traditional network, right? There are some of the concepts of VPC is it's the fundamental networking layer in EC2. Not only EC2, for multiple other services such as RDS, even for Lambda and so on and so forth. VPC, right? It's called Virtual Private Cloud. Okay, I mean, you are subscribed to a public cloud, but within your public cloud, you can build something called a virtual private cloud, which is private only to you. It's not for others. No one else can come and intrude into that, right? Similar to the power example, once I create a connection in my home, right, with all devices and everything, all appliances, and once the power comes to my board, the main meter board, and there's also a meter in it, no one else can take away power from that, right? I mean, it's only for me. That entire premises is mine, and that is guarded only by me. Okay, that's called it's a virtual network dedicated to your AWS account. Okay, no one else can intrude into that, or no one else can peep into that. Okay, again, a subnet. It's a range of IP addresses in your VPC. Okay, so now again, let's take the power example, right? I mean, I'm building a house, right, and I need to give power to all my rooms. Okay, so now what will I do? In each room, I will have some sort of a small junction box, correct? Which will distribute the power, right? I will draw the cable from there and give it to all the appliances that I need in my room, in my house. So now imagine each room is probably like a subnet. Okay, each room has got its own boundaries. That's called a subnet, right? But in the networking, a VPC is my entire house. Each room is basically a subnet which has a range of IP addresses, because you may want to uniquely identify all your EC2 instances devices that is running in your home, right? So that's why you have subnet. Okay, route table, I'll come back to it in subsequent classes, internet gateway and all of this, I'll come back to this. But there's one thing which is very important is CIDR, right? Cidr block, right? It's called classless inter-domain routing. So now CIDR is a terminology that is used to create some sort of a notation for your IP address. Okay, if you read through this CIDR notation Wikipedia article, you will know, right? What is a CIDR? It's a compact representation of an IP address and associated network mask. Now, in your home, you have a router and you have a modem, correct? So now you will have an IP address associated with your laptop or your mobile device. Okay, it will be in the range of whatever 192.168.1.5, 192.168.1.10, right, and things like that. So that 192.168 1.1, 1.2, 1.3, 1.4, 1.5, all of that is represented by a CIDR notation, CIDR notation. Okay, it is called CIDR. Okay, so now it provides a CIDR block, and also read through this, which will be very interesting. In fact, I'm going to give you some assignments for today, where you'll have to read through all of this and come back tomorrow. Okay, so that you can appreciate the overall VPC. So for now, remember that VPC is a virtual network dedicated to your AWS account, and that will have an IP address range. Okay, sorry, somebody has to go on mute, please. Please don't unmute. Please, I request again, please don't unmute. It's disturbing all the others as well. Okay, VPC is a virtual network dedicated to your AWS account, and subnet is a range of IP addresses in your VPC, right? It's basically like the rooms that I mentioned, right? You've got rooms, multiple rooms, and each room you can call it as a subnet. Okay, so that's what you can imagine of. So now again, IP address range, right? Now, what is an IP address range, right? What is an IP address? IP address is a unique address that is given to your laptop or desktop, right? So now, if I say if config or IP config in Windows, right? If you use Windows, you will use IP config, but in Linux or in all the other operating systems, it's called if config. Mac, I use Mac. Now, if you see, what is my IP address? 1 second, let me just look up. Yeah, this is the IP address of my EN0, which is my Wi-Fi adapter. So it has an IP address of 192.168.1.10. Okay, and my gateway device would be 192.168.1.1. So that will be my router. Okay, similarly, you can also try. Just open a command prompt and say type ipconfig, and you will see this IP address, right? So each device in your network is uniquely identified by an IP address. Okay, that is very important, right? And IP address cannot repeat. Okay, you cannot have overlapping IP addresses, because then there will be a conflict. Because when the network packet has to be sent or routed to a specific device, right, it has to be identified by an IP address. Like it's like a mobile device, not mobile. Every mobile number is unique, correct? Because you can't have repeatable mobile numbers, or you can't have overlapping mobile numbers, right? So then someone else can't have my mobile number, right? So that's very as simple as that. So that way IP address is very, very important, and there is a way to represent your IP address. So that's called the Cidr notation. Cidr notation. Okay, if you see, a Cidr notation is the way to represent your IP address in the internet, right? Even if you take in the internet, the public IP address, so there are two types of IP addresses: IPv4 and IPv6. Sorry, please give me a second. There's some noise. It's raining heavily. Let me just close the windows. Okay, so CIDR is a notation that is used in representing your IP addresses. There are two types of IP addresses: IPv4 and IPv6, right? Now IPv4 is the older version, right? IP version 4. So it's already exhausted, right? So because there are only these many IPv4 addresses that are available, that can be available. Now, in the internet, you need unique IP addresses, correct? Otherwise, you can't have overlapping IP addresses in the internet. Again, there are two types of IP addresses: public IP address, private IP address. Okay, I'm talking about the public IP address. Even for your router, you will get a public IP address. Okay, you can check that. What is my IP? Right? If you go to Google and say, what is my IP? Yeah, so this is my IP address. Unique IP address. No one else will have this IP address. All of you can check. This is your public IP address. Whereas my private IP address is this one: 192.168.1.10. Okay. Now you may wonder, what is the public IP address? What is the private IP address? Just wait. You will get answers to that. So now IPv4 is all exhausted. So now there's a new version called IPv6, right? Which gives you a lot more widespread ranges of IP addresses, so that, because today, if you see, the number of devices have increased, right? Not like what it used to be 10 or 20 years back. Thanks to IoT and thanks to edge computing, pretty much every device that you take is connected to internet, correct? Including ACs, including water heaters, refrigerators, and so on and so forth, right? There's so much of device sprawl that has occurred. So the available IPv4 address range is not sufficient to connect all of these billions of devices across the world. That's the reason IPv6 is there. So read about this Cidr, right? I mean, there's a assignment that I'll give you for today to read about the Cidr, and more importantly, understand how the Cidr notation is represented. So there is a site called cidr.xyz, a very favorite site of mine, where you can know how the Cidr notation is described, and you can test it, right? You can say 192.168.1.0 or 0.0/28. Okay, you see this /28, that is called the subnet mask. Okay, because we want to split your network into multiple smaller subnets. Subnets, what is subnet? Subnet is subnetwork. Okay, you want to split your network into multiple smaller subnets. Each subnet will have a notation of / some number associated with it. Okay, that's called the subnet mask. Okay, so now when you say 192.168.0.0/28, the first usable IP in this range would be 192.168.0.1, and the last IP would be 192.168.0.14. It will give you 16 IP addresses for this subnet mask. Okay, and this is the net mask. If I want more, I will reduce this count. If I say 24, because it's called an octet, right? I mean, each number that you see, right, in an IP address, it's called an octet. What is an octet? I mean, we would have learned about this in our schools, right? When we learned binary, or even in colleges. Okay, an octet is which comprises of 8 bits. Okay, so this is an 8 bits, and it's basically an octet, right? If you see here, 11000000. It's a decimal. Sorry, it's a binary. Right? It's a binary representation. So each one is an octet. Okay, and in this case, if you see, starting IP address is 192.168.0.1, end is 192.168.0.254. It gives me 256 IP addresses on the whole. If I want to even increase it, right, I can make it 20. I get 4,000. So you see that this is increasing when in a binary model, right? I mean, what is binary? It is 2, 4, 8, 16 to the power of 2, right? It's a binary, correct? So 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, correct? So you will see that it increases at this range. See, 19 would be 8192, 18 would be 16384, 17 would be 32768, 16 would be 65536. If you go for a VPC of /16, you will get 65,536 IP addresses, which means that you can spin up to 65,536 EC2 instances. Okay, each device or each EC2 instance can have an IP address from within this range of 192.168.0.1, 192.168.255.254. Okay, so technically speaking, you will get 65,536 IP addresses. If you further reduce it to say 8, how much it is? 1,67 lakhs, correct? Yeah, 1,67 lakh IP addresses you can get. Okay, so now if you see this, IP addresses contains 4 octets, each consisting of 8 bits, giving values between 0 and 255. Each is between 0 and 255. So this is the decimal value. Okay, but it's actually represented as a binary, because at the end of the day, every data packet that goes is in the binary format, right? It's in the format of zeros and ones. Okay, so that's how you have a range of IP addresses that you define, and what is the standard that you follow? It's called CIDR, Classless Inter-Domain Routing. And I want all of you to read through this article of Cidr notation, right, in the Wikipedia, right, and it has got some interesting stuff with respect to, there are standards that are defined. It's called RFCs, right? RFC is a standard terminology that is used to define standards, right? So because in networks, And everyone has to follow standards. All the device manufacturers, whoever is building these networks, they all have to define the standards, right? For example, in power distribution, there is a standard that is maintained in India, right? The standard is it can be 220 to 240 volts. It cannot go beyond 220 to 40 volts, correct? Or come below 220 to 40 volts. Correct? Whereas if you go to the US, in US it is 120 volts, right? It cannot go beyond 120 volts. Right? If it goes beyond 120 volts, any electrical appliance that you buy in the US, and if you try to plug it into a power socket which supplies 240 volts, will burn, will short. And that is a standard. So these are all standards that are defined. Even here, there's something called RFCs that defines the standards for what should be the IP address range and how should the IP address range be well defined. So the need to well define this is to ensure that you follow some standards so that there is good interoperability between networks, right? And when companies are building, like say tomorrow a new cloud provider may come up, he will also follow the same standard, right? I mean, if he doesn't follow the same standard, he will not be able to interact with other cloud providers or other networks in the world. Okay, so that's why it's very important that you understand this. So now we spoke about IP address, how the IP address is represented. We spoke about VPC and subnet, right? So now let's do a quick lab on how to create a small VPC. I'll just bring up something. Just give me a second. Okay, before that, I will also show you something else as to how this VPC can be connected to your corporate network and how logically it looks like. Yeah. So now we have this network, right? So we have this network. And where this is the red box that you see is your private office network, right? It's a private network where you have all your devices that you built and you have invested on all this, right? Such as the core switches, the cables that run from one floor to other floor, data center, all the equipments that you see in the data center, everything is invested by you. Okay, so now imagine you are running an organization and you have a small data center which is supporting the applications and workloads that you are using. Okay, suddenly there is a change in the business model and your board has approved a spin-off of a new business or a new product. Okay, and the board has approved it and now you want to start that new product, but in order to build that new product you need more compute capacity. Okay, but your data center is probably only 2000 square feet, okay, in real estate, and it's already full and it already has, sorry, please go on mute. Yeah, it already has reached out a capacity and it's already full. So now what will you do? Your board or your management has given you a mandate of creating a new service or a new product in the next 3 months and launch it in the next 3 months. And in order to, the time is very short and you want to build it as soon as possible and launch it in the next 3 months. So what will you do, right? You can't extend the walls of your data center, correct? Because it's a physical building. And you can't add more devices because it's already full. And you can't go for a new place also because going to a new place is a long journey, right? I mean, it can't happen in 1 or 2 months. And remember, the time that is given to you is only 3 months to complete this whole project. Okay, so now you can't rent a new place because the capital expenditure of that is very high. You have to find a place, you have to find the right connectivity and all of that, correct? It's all very time consuming and the time to market, you'll not be able to meet your time to market requirements. Okay, so that is where you can logically extend your network to AWS, where you create a new AWS account in any region. Maybe if it is in India, you create it in Mumbai region, or you choose Mumbai region and you create an AWS account. Within Mumbai region, you provision a new VPC. What is VPC? VPC is just a logical extension of your private network. You have a private network, this red box that you see, correct? It's your private network. VPC is also red box, correct? Because it's a logical extension of your private network, but it has got a different IP address range. Okay. In your on-premise, you have 192.168 and you have 10.0.1.5, right? So whereas in your VPC, you have 10.0.2.5 range, 2.5 to 2.500 and 10.1.2.5 to 10.1.2.500. So you provision your instances into availability zones and you give an IP address range of 10.0.2.5 to 10.0.2.500 to one availability zone through the subnet. What is subnet? Subnet is again, it's a subnetwork, right, within the VPC. And for the other subnet, which is in the other availability zone, this can be another availability zone. You give 10.1.2.5, 10.1.2.500. So that way, you get additional 500 plus 500,000 servers you get on cloud. Okay, with which you will again you can connect your private office network to your VPC through a VPN connection or a direct connect connection. Okay, so that a device sitting in one of the on premises will be able to talk to the EC2 instance which is running in AWS and vice versa. Okay, through this connectivity. Again, this connectivity is optional. You can do this connectivity or you can just leave it. Right? I mean, depends on your net, depends on your requirement purely. Okay, so now imagine, I mean, this is a great boon for enterprises or organizations who have already been saturated with respect to the capacity that they can further invest or that they already have. For them, they need additional capacity, right? They need additional servers. They can simply provision a new AWS account like what you all did a couple of days back and start using it from day one. So now the 3-month deadline that is given to me by my board to create a new product and launch the new product is achieved very easy. Now all that I need to do is to just set up a small network on AWS, start building my product, right? And that will give me the environments that I require to develop and test my product and then launch the product in AWS itself and then take it live in the next 3 months. This wouldn't have been possible in a traditional private network, right? This because it's already done, right? I won't be able to add anything. I should only tell my board that, sorry, Mr. CEO, I won't be able to do this because the time that's given to me is very, very short. Okay, to build the infrastructure. That is the power of cloud. Okay. So let me just go to my console. So I'm in Mumbai region. Okay, so here let me type VPC. You will see VPC. Select a VPC, select the VPC link. It will take me to the VPC console. Okay, and if you see here, this is a dashboard that shows the VPCs, various subnets, right? I mean, for now, just focus on these two. Rest of it will come back later, right? On the left side, if you just click on your VPCs, it will show all the VPCs that I already have. Okay, it shows all the VPCs that I have. It will show all the subnets that I already have. Okay, so now let's do one thing. Let's create a new VPC. But for that, let me just go ahead and clean up some certain things. Actions, VPC. Okay, so when you log into your AWS account, when you create your first AWS account, by default, AWS provisions a default VPC in every region in your account. For example, in Mumbai, I've got this default VPC. If I go to say Singapore. Yeah, you will see a default one VPC. In every region, you will have a default VPC and subnets associated with the VPC, right? I mean, in this case, if you see, Singapore has got 3 availability zones, AP Southeast 1A, 1B, and 1C, right? So that's how availability zones are split. This is the notation, right? For example, I told you the other day, right? What is how the region is represented? A region is represented by AP. AP is Asia Pacific hyphen Southeast, right? Singapore is all Southeast, correct? Southeast Asia, because they're all Southeast Asia hyphen 1. Okay, that's how Singapore is represented. Singapore region is represented, okay, hyphen 1. But within the region, there are 3 availability zones. Each availability zone is represented by A, B, and C. Okay, and they've got a unique ID as well. Okay, so now that's how. So let me come back to Mumbai. In Mumbai, how many availability zones are there? Again, in Mumbai also there are 3 availability zones, as I said, correct? Availability zone 1A, 1B, and 1C. Okay, and there are 3 subnets that are created. So by default, you will have this VPC, default VPC. So you don't have to worry about it. If you want, you can delete it, or you can simply ignore it and move on, right? But when you provision any resources, you have to select the right VPC so that your resource goes into the right VPC and gets routed properly. So that's where you should not get confused. Okay. So now I will go and create a new VPC. I will create a VPC called my VPC. Okay. In fact, I've got a lab session for you today, and I'm going to give you this. Okay, I'm going to give you this. You will create your VPC according to this diagram that you see here. Okay, so in this case, this is my AWS account. This blue box is my AWS account. The red box that you see is the VPC. Okay, in region Mumbai. Okay, now I'm in Mumbai, right? I'm in Mumbai. Okay, and I'm going to create a new VPC. Okay, and what is the IP address range that I'm going to give? What is the name? Name is my VPC. I've given name as my VPC. And what is the IP address range I'm going to give to my VPC? It's 10.0.0/16. So remember, what is 10.0.0/16? Go to CIDR.xyz and type 10.0.0.0/16. Okay, the first IP is 10.0.0.1. The last IP is 10.0.255.254, which gives you 65,536 IP addresses. Okay, so that is what I'm going to choose now. So in VPC, in AWS, okay, VPC has got, by design, the requirements is you can provision a maximum of /16. Okay, so in this case, it's the reverse, right? I mean, if you see, the more and more you reduce the number, the count increases, correct? If you increase this, right, to 20, the count reduces. If you make it 24, the count reduces to 256. If you make it 28, the count further reduces to 16 IP addresses. Okay, and if you reduce this subnet mask to 16, it increases. If you further reduce it to 8, this further increases. Okay, so now what AWS gives is, in a VPC, the minimum that you can provision, okay, is /28. /28 is the minimum subnet that you can provision in a VPC. The maximum that you can provision is /16. See this? The smallest CIDR block you can specify is /28, and the largest block is /16. So remember this. This will be an interview question. This will be a question that will be asked when you do certifications, when you do other things, right? When you actually work on design and things like that. The smallest CIDR block you can specify is /28. Remember what is /28? /28 will give you 16 IP addresses. That is the smallest that you can choose when you provision a VPC, new VPC. The largest that you can do is /16, which will provide 65,536 IP addresses. Okay, so it is /28 and /16. That is the range that you can do, and within that you can give any range, right? You can also go for /24, which will give 256. You can do /20, which will give 4,000 IP addresses. Depends on your requirement. Okay, so now in this case, let's go with the largest block, which is /16. I want to choose 10.0.0.0/16. And how do I know that I need to choose 10.0.0.0/16? So that is where you have something called RFC 1918. So now what this RFC does is, RFC is again a standard which is defined. Okay, read through this RFC. What this RFC does is it gives you an address allocation for private networks or private internets. Okay, so for the purpose of an entity account and operating a network using TCP/IP, and in particular determining the addressing plan and address assignments within that network. So here, if you see, it clearly defines what are the private address spaces that I need to use. So these are the 3 private address spaces that you can use when you're building private networks. Now, in this case, this is also private network, right? I mean, I'm not saying this is a public network because my VPC is private to only me, right? Similar to your office network, physical office network, my VPC is also private to my network. So in that case, you have these, you can only use these 3 IP address ranges. Okay, which is 10.0.0.0 to 10.255.255.255, which means that 10.0.0.0/8. Okay, here 172.16.00/12. In this case, 192.168.00/16. Okay, so these are the 3 ranges that you can use. So now, when you create VPCs, you can use one of these ranges. But in this case, you won't be able to use this /12 and /8, right? Because VPC does not support /8 or /12. The maximum that it supports is /16. So here, what you can do is you can go for 10.0.0.0/16. Instead of 8, you can go for /16, which will give you 65,000 IP addresses, 64,000 something IP addresses. Okay, and here also you can do 172.116.00/16. Okay, so now let's do this 172.16.00/16. Yeah, this gives again 65,536 IP addresses. Okay, so remember that you always have to use one of these 3 ranges when you create VPCs. So now let's go back. So I'm using one of those IP addresses here in my assignment. What am I using? I'm using 10.0.0.0/16. So that is within this range, right? That is within this range, Okay, so I'm complying with my RFC and also my VPC requirement. So I will give that 10.0.0.0/16. This is my IPv4 CIDR block. Here you can choose an IPv6 also, but for now I will just ignore it. We'll come back to IPv6 later. Tenancy, keep it as default. Don't go for dedicated. Dedicated will have different cost implications and so on and so forth. But right now, just go for default and give a name tag. So moment you give a name here, this will be populated here as name equal to my VPC. Just click on create VPC. Okay, perfect. Now my VPC is created. What is my VPC here? This is my VPC. Okay, the VPC Cidr range is 10.0.0.0/16. Okay, that is done. So VPC, this red box is now created. So now let us create this yellow box. Yellow box is my subnet. Okay, this yellow box, 2 yellow boxes that you see are 2 subnets. My one subnet is 10.0.10/24. So now remember, the IP address range that you choose for your subnet has to be a subset of your VPC's range. Okay, so now my VPC range is 65,536 IP addresses. So now here I'm giving 10.0.10/24, 10.0.20/24 for subnet 2. This is subnet 1, this is subnet 2. Let us see what is this range, 10.0.10/24. 10.0.10/24. Okay, this gives me 256 IP addresses, and you see this range. This is within my VPC's range. VPC has got 65,536 IP addresses. Now, out of that, I'm taking 256 and I'm creating a small subnet out of that. That's all. Okay. So now that is what I'm doing. Also have the IP will be 1 to 2 to 2 to 4. Okay, so now what will I need to do in order to create subnets? I need to go click on subnets. Okay, so now you will already see some subnets for your default VPC with the different ranges. Ignore this. Just click on create subnet. Here you have to select a VPC. Select the new VPC created. That is my VPC. Okay, and then it will tell you what is the IPv4 CIDR range for my VPC, which is 10.0.0/16. And here I will give my, so what is the name I have given here? Subnet 1. Subnet 1 is the name that I have given here. You save.
Your voice is breaking, sir.
In the box.
Voice is breaking, sir.
I'm not able to hear, sir.
Is it
Voice is not here, sir.
okay? Just give me okay. Yeah, am I audible now?
Yes, sir. Yes, sir.
Okay. Okay, all right. So if you see this, just a second. Yeah. So if you see this, I created the orange box. Sorry, the yellow one. Yellow box is a subnet, but outside that yellow box, you see a black box, correct? So that is the availability zone. So your subnet can be associated with an availability zone, right? Now in this case, I'm creating this subnet in the availability zone 1, this subnet in the availability zone 2, right? Which means that remember within a region Mumbai, there are multiple availability zones. There are 3 availability zones. Each availability zone is distanced by about 100 kilometers, less than 100 kilometers, and they are connected with each other through high-speed network, low latency, high-speed network, high throughput network. Okay, that way I can, if I need 2 EC2 instances, for example, if I need to build a website, I need multiple web servers, right? I can put one web server on one availability zone in the subnet 1. I can put the second web server in the second availability zone in the second subnet. That is the reason why you need to always associate a subnet with an availability zone. So when you create a subnet, you have to choose. I mean, in this case, you can say no preference. AWS will decide which availability zone to place this subnet in. Okay, but in this case, I don't want to give that choice to AWS. I want to make the choice. I will put it in the first sub availability zone, which is 1A. And what is the IP address range for that? 10.0.10/24. 10.0.10/24. This range is within this range of 10.0.0/16. It has to be within this range. If I choose some other range, right, some other IP address, let me give 92.168 0.1/24. You know, it will throw an error. See, Cidr ranges is not within the Cidr range address from VPC. So it will throw that error. So now I have to go for 10.0.10/24. That is the IP address range that I need to give. I will create the subnet. Yeah, if you see, the subnet is created. Okay, I will also create a second subnet called subnet 2, which has 10.0.20/24 and availability zone 2. Select the VPC, which is your VPC. Subnet 2, that is the subnet 2. And the availability zone, select 1B, right? I want you to select 1B, which is second availability zone. 10.0.20/24. Right, 10.0.20/24, and create the subnet. That's it. So now if you see, you can select a particular VPC from here. Yeah, I'll select my VPC from the left filter box. You will see this. I have one VPC and two subnets as per this architecture diagram. Now my network is set up. See, as simple as this, right? Your network is now set up. Your private network is set up, and you just need to start provisioning your resources in the respective subnets and start using it. Okay, so that's it for today, right? So this is the assignment for today. I'm going to give this assignment. So what I want all of you to do is to go through this first, right? So first go through all of this. Okay, first go through all of this, and then do this assignment in your respective accounts. Don't worry if you still don't have an account. You can pair up with somebody, right? And mentors, please take care of that. I mean, if some of the students don't have accounts as yet, I mean, they can join hands with other people. They can form groups and start doing this lab activity for today. Okay, so do this, and it's very simple, very straightforward. Once you do it, you will understand. But more importantly, don't jump into the assignment straight away. First, start with the fundamentals, start learning this, right? Go through all of these, right? And then get into the assignment.
One small question, sir.
Yeah.
We have created this VPC and subnets. What about the EC2 instances also? We need to, can we select the availability zones? No, right?
No. You don't have to. You will only select the subnet where your EC2 instance will go. That way,
so normally,
by default,
do we have this option to select each instance in different availability zones?
No, you will see what you're creating now is a template, correct? You have created a VPC, you have created subnets. Each subnet corresponds to an availability zone. So when you provision EC2 instances, you choose the subnet. So now, since there is a one-to-one mapping between a subnet and an availability zone, you can choose where you want to place your EC2 instance and in which subnet. That way, you can place it in multiple subnets, each subnet being in different availability zones.
So normally we don't have any chance to select this EC2 instances in other availability zones, I guess, right? You can
through subnets. You can.
Okay. So
that is the reason why you have subnets.
So while creating these instances, it gives us any option to select this availability zone also.
Yes, you can choose the subnet where you want to create. So now, remember, subnet is married to the availability zone, correct?
Yeah. So once
that way, when you put it in a subnet, it will go into the availability zone. Yeah. Automatically, it will go into the availability zone.
Once I select that subnet, so automatically that EC2 instance will be created in that zone.
Correct.
Okay.
Excuse me, sir.
Don't worry about right. Just focus on. Sorry, somebody has to go on mute.
Excuse me, sir.
Sorry, please go on mute for a second. Yeah. So to answer your question, don't worry about EC2 instances right now. When you learn the concepts of VPC and subnet, a lot of those things will be easy, right? So my request is don't jump the gun for now. Even though your hands might be itching to do some EC2 instances, wait. Right, so these are very important concepts. Learn this thoroughly and then go to EC2 instances. Right. For now, just do these assignments of creating a VPC and subnet as per the architecture diagram that I'm giving you, and then you can go on from there. Okay, I'm going to put this in the chat window. Okay, I will copy this file to the chat window, and then you can start using it. Yeah, I've just put it in the chat window, so you can just download it from the chat window and start reading through that. And tomorrow, please be on time at 8:30. Right, let's get started. First 10 to 15 minutes I will dedicate for any queries or question and answers. Okay, and then we can get into the class for tomorrow. But please be on time tomorrow at 8:30, right? And then we can take it on from there. So till the meantime, please reserve all your questions. So just wait for some time. Go through the assignment that I've given you today. I know all of you have a lot of curious questions, but please wait till tomorrow morning or till you learn this for today and complete the assignment for today, and then we can catch up tomorrow morning. Okay, all right, then I'll leave you all here, right? You can go into your respective breakout rooms and start doing your assignment and start learning, and I'll see you all tomorrow, right? Have a great day. See you. Bye.
Thank you, sir.
Thank you very much, sir.
Bye.
Thank you. Bye. Bye, Krishna. I'll drop off now. Okay.
Sir, we didn't get any document in the chat box, assignment chat box.
Yeah, there is a one-page Word document which actually is being sent to everybody in the chat box. I could download that. Yeah.
Krish, are you there?
Sairam guys, sorry, I think I was talking with another mic which is not active. Sorry, I apologize. Thanks, Muliana, for answering that. Yes, we have the document able to download. I will send that to your mentor, so you can also get it from your mentor if you are not able to download it from here. We'll open breakout rooms now, and guys, please do practice there whatever Prasanna sir shared just now. I know you may all want to explore a little bit further, but I think I would recommend wait until Prasanna sir covered that particular topic. So that
Multiple users are not going right. Right. No, I'm not with the server perspective here.
Go ahead, Krish.
Okay, sorry. So I would recommend you to wait until Prasanna sir give you the instructions how to access this particular service from AWS. I know it's user friendly, and all of us want to get into go and explore our own. But I think if this is the basic foundation side, but if we get to know the best practices to do, I think it will really helps us in our work area as well. So just stick on to the topics that Prasanna sir covered today, and then you guys can get into the EC2 set tomorrow or further on. So Murliana, thanks for joining us. I'll introduce you with the respective breakout room now to to all the mentors, we have another additional a male mentor, that is Sai Mulyana. I think most of us know. I'm assigning you to room number 7, Mulyana. I'll come there and introduce to the students now.
Okay.
Yep. Thanks, guys. Please do join your breakout room sessions. And as Prasanna sir mentioned, make sure to set your alarm back to 8:20, and please do join 5 minutes before the class, because it will bring up the enthusiasm to the tutor as well. So try to be on time.
Sure.
Guys, could you please join your breakout rooms? I have around 12 students who didn't accept the breakout invitation yet. Vijay bro, were you able to join?
Hello.
Yes, ma'am.
Brother, I added today. This is my first class. I don't know like what are breakout rooms, and I was not allocated to any mentor. So I got this information through mail. So I can join from Google.
Okay.
So,
Sure, ma'am. Yeah, you'll be assigned to a student ID. For now, I'll be adding you to room number 2. Please be in that room, and then one of us will give you a student ID. And from starting tomorrow, please do rename your profile title with the student ID.
okay, brother. Thank you.
All right. Yep.
Yeah, hi, Sai Krishna bro. Yeah, this is Vijay.
Jason. Yeah, Jason.
Yeah, okay. Yeah, thank you.
And Prayanna, can you be here for a while? I mean, sorry, room number 7, Kelle. I'll just introduce mentees to
Sure.
Mulyana. I'll come back. Anna, Mulyana, ekkada panchestunna? IBM kada?
IBM, correct. IBM, right.
Okay, done. I'll be back here soon.
Hello, sir. This is Siraj. I have joining the classes from 24th November. Today, ma'am has said me that she will give me an
Student ID?
ID number.
Sure. Which madam, ma'am? Do you remember the name?
Harsha, her name is.
Okay, sure. So we'll assign you an ID. For now, I'm joining you to group number 3. One of the mentor will give you the ID and details. Okay.
Okay, thank you so much.
Sure.
SC58, SP67. You still seems to be in the main room. have you not received invitation for the breakout room?